Going live. I think we're live. Yep. By 6 seconds, we are live. Audios. All right. Oh, this chair's a piece of fucking garbage. Okay. Ha. Hi, everybody. Okay, so today's live stream is on the bench, and the whole point is we're going to be working on building the circuit that we've been designing for the past couple weeks. So that should be fun. I think that should be fun. And, all right, pardon me while I reach out and start doing some... all right, so you'll notice the camera setup is different. I actually have the camera set up on the bench. And then I literally just set up this face cam just now, today, for this. So it's not optimal, but it's here. So what I'm going to do, I'm not in front of the computer, so your comments, I am going to watch the stream live. Hey, that works. Turn the volume down on this, and I'm going to watch the stream live so that I can see the comments as they come through. Hey, babe, I see you're in there. My greatest fan. Absolutely. Aside from the squirrel cage one that I have in the room. Ha 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 ha. Because get it? It's a fan. I'm an HVAC professional. I work with fans. All right. So let me do a little shameless plug here. And I say shameless plug. Gonna advertise on the social medias. I should be able to go to my channel, to my thing, and yep, share that link, copy the link, and then we're going to go over to the Facebooks, and we are going to share this. There's so many buttons to push. Am I the only one that ever gets like frustrated with how many buttons there are to push? We are live, all caps. Live. Exclamation points, because the Queen of England loves them. Loved. God rest her soul, I guess. All right. Ta-da. I actually like the picture they chose. I let YouTube choose the picture. I think it did all right. I don't mind that picture. Yep. And then I'm just going to go over here and share again for more Facebook clout. I just forgot what I was going to say. Oh, yeah. Because I'm smart that way. Are live. Share now. Okay, now that that's all done, let us actually do some stuff. So like I said, I am not in front of the computer, so I'm watching the comments on a phone that's in front of me. So, by all means, everybody is welcome to bring their A game for dad jokes today. They are always welcome. And what we are going to be doing is building the circuit that we've been working on this here breadboard. Let me just make sure that's in frame. Yep, that's in frame. So, I have my components, so let's walk through the components we need. Got a board to put this on. I'm actually going to have to enlarge the holes for this board because our transformer doesn't quite fit through. Now, let me pull up the schematic that I drew out there in my old pictures over here, and this one. Okay. So, if I go by the schematic, right, we got our transformer, okay, we're going to need rectifier. Now, I originally was going to use these here diodes, which I don't remember the number to. These are 400 volt diodes, but since I am dropping the voltage with a transformer to 8 volts RMS, we can go with these here 50. They're bigger. Why? Well, all right, whatever. We're going to go with these here 50 volt diodes. And of course that turned off. because why wouldn't it? All right, so if you're looking on here, can you see this? Sort of right there. So if you're looking on here, we need 4 diodes for the rectifier, right? And then we need 1 diode for the DC circuit, the DC bus on this. So that's 5 diodes. What do I have here? I got 1, 2, 3, 4. Need 5. Ta-da! So 1N401. Plenty fine. 50-volt diodes. This should work perfect. So there's my diodes. So transformer, diodes, rectifier. Now we need a 100 ohm resistor. So we go to our resistors here. And we pull up the 100 ohm. Oh, bloody sakes. Resistors are an absolute pain in the butt. That's 200. You know what? We're going to need a 220 ohm. I do know that. So let me pull out a 220 ohm resistor. Ta-da! Okay, 680. Don't care about that. 6 million. Why? Whatever. Anything over 1 million is useless to me. They do not have these in order. Yay! I literally just got this kit because my my selection of resistors. Oh, here we go. I found it. 100 ohms. All right, and I do like to confirm my resistors by measuring them. You know, it just seems like a good idea to confirm your resistors before you build your circuits. Now, I also need a 2 50,000 ohm resistors if I'm going over here. So, oh, that didn't work. Yeah, so I need 2 50 ohm resistors right there. I have my 220, have my 100, need my 250K resistors. Actually, the 50K resistors, that's not as critical. That can be over 50K. Shit, honestly, it could probably be 1 million. But the important thing is that they're the same. So the voltage drop is dictated by the resistance across the two. If the two resistors are the same, then the voltage drop is 50% of source voltage. 47,000? And 50... That's 1. Wow. 1 ohm. They really stashed this kit with some useless stuff. What is that? That's 510,000. Wow, this is really disorganized. 68, 30, 33. Went from 68,000 to 33. 300, 33, 22, 3R. You know, honestly, it might actually be faster to look for the colors. Why do I have so many 200? That's 5,000. So how's everybody doing tonight? So I had an interesting day. So I went to get a haircut just to look good for you guys. And I went to get a haircut. The barbershop's not far away. But on the way home from getting a haircut, my truck decided to blow the bottom radiator hose off of the radiator. Like, clean off of it. Like, this thing had some force behind it. And it then excavated my entire coolant system probably within like a minute. Now, thankfully, I live pretty close, so it wasn't, but oh my god, are you seriously right at the bottom? What a... I'm not... 0? Frustrating. 47. No. You're kidding me. Oh, here we go. I went right by it. All right. 51,000. Doesn't matter as long as they're the same. And really? All right. That's it for the resistors. And I got some cabbage in my tooth. Okay, so my truck proceeded to dump all of the engine coolant in a very quickly, very fast, rapid fashion. And literally, as I was pulling into my development, the thing starts yelling at me, you're overheating. So that was fun. And of course, this was already planned. Okay, I'm getting off subject. Let's do this. Alright, so the next thing I need on the parts list. Alright, so I have my resistors, resistor. Alright, this is actually a potentiometer right here. And I have that potentiometer, 100,000 ohm potentiometer right here, 104. So we got that. Good. Alright. 1,000 microfarad capacitor. Got that. Check the rating. 1,000 microfarad, 16 volts. We're dealing with 5 volts, so that should be good. And, oh, for bloody sakes. And comparator. Right? Capacitor. Oh, nope. Forgot the Zener diode. Alright, so I got a Zener diode here. Now, the Zener diode is like a pressure relief valve, right? So it's like a check valve. So like a diode is like a check valve. Makes sense. A Zener diode is like a check valve that has a pressure relief to it. And these are set to 5.1 volts. So that means if the voltage source on the DC bus goes over 5.1 volts, this will start passing current to keep it from going over 5.1 volts. Now, according to our simulation, the current, so these are 1 watt, and the wattage going across was like 100 milliwatts. So, should be fine. Worst case scenario, this is one I was thinking about using, but I don't know the rating on it just yet. So we have our resistors. Ta-da! Alright. And then we have our comparator. So this is a, what is this? I forget. It's an LM393. It's actually a dual comparator. We only need one side. Still works fine. So, comparator, and the last part of the circuit. Do I have the last part shown here? Yes, the opto isolator. And I have the resistor for it. That's this. Now, the back side of the opto isolator I do need to build. That is also going to be to a 220 ohm resistor. Oh, I gotta go back in this thing again. Oh man, I almost need to apologize. That's 22. So I should have pulled. That's what I get for not having it written down. But I gotta get another 220 ohm resistor. See if I can find it faster than up 200 ohm. 22,000 ohm. I need to organize this. I need to find a better way to organize my resistors. So anyways, hopefully the truck, it's an LQ4 engine. They're fairly robust. Hopefully it doesn't. It definitely overheated. Definitely overheated. But that doesn't necessarily say how far it overheated. And I'm going to say this. Like, it honestly looks like... I put a picture on the Facebooks. It does actually look like, oh, he didn't tighten down his clamp. And every Yahoo mechanic's going to be like, oh, he didn't tighten down his clamp. The thing is, I'm actually wondering what the oh, it's going to be the last one. It's going to... These are not These are not great. Looking for resistors is an absolute pain in the fucking ass. The clamp was not loose. That's 200. That's 220. That's 220,000. And they're all that 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, they're all there. Just wanted to make sure I didn't grab a 220,000 before and call it a 220. 33. Oh, there they are. Found them. Gonna grab an extra one. And that is to limit the current on the other side of the opto-isolator. Yes. So yeah, hopefully the engine isn't it'll be alright. Hopefully. They can take a beating. But what I'm actually wondering is dropsies. Of course I dropped it. I wouldn't be me if I didn't drop at least 100 things today. I swear to God. Cool. I see nobody's posted any other comments or dad jokes or anything in here. All right. Now, should have two 220 ohm resistors. Should have two 51,000 ohm resistors and one 100 ohm resistor. 5 diodes, 1 capacitor, 1 Zener diode, 1 potentiometer, transformer. All right, so I think we got our stuff. Now we got to start putting it together. Now what I'm intending to do is put this together in a way that I can use it for multiple projects. So I'm just going to make this as like they call it a breakout board. So if you kind of want an idea of how this is going to go, this is pretty much what it looks like when you build circuits, you know, on a project board. So that's what we're going to end up doing. I have these here. I just got these in. These are bent over, oddly. These are 5 volt, 110 to 5 volt power supplies that are like 300 milliamps. And they just come apart like this. So that's a 300 milliamp, 110 to 5 volt power supply. I'm pretty darn certain that's a switch mode power supply. Which is not terribly useful. I wanted to get it to C because this transformer, you'll see, is very similar to this transformer, and I was trying to get them as small as possible. So if this transformer is a standard 60 hertz transformer, I might just rob it off here and make a different circuit using that one, because that is nice and small. But for all I know, they're using it at high frequency, and maybe it won't work because it could have a different core and stuff. So today we're using this one. This one is guaranteed to work. All right, now let's lay this out. So all right, so this is my primary side and secondary side. There's 2 secondary coils, right? I'm going to have to ohm them out to see which ones are which for sure. Or I could apply a voltage, but what I'm thinking is I'm going to use I need my pens. Oh, here's some pens. I'm going to use normal breadboard pens like this to create my connection point. That way I can just make the connection pretty easily as a breakout board. I can just take my power to there and then take a signal away from it. Alright, now I need to mark out which holes I gotta drill. You would think I want it to be away from here, so I have my connection point right there. you know what? I can do it. I can do it one row closer. Yep. And that gives me this row right here. This is not going to be the most beautiful arrangement that I've ever done. Looking for a marker. Of course, I don't have a marker readily available. What kind of operation do you think this is? Can't be shade tree if it's not shady. Unfortunate. I'll use a pencil. With a mirror stuck to it. Because we do interesting stuff. Alright. I don't know that that's working. Alright, we'll wing it. Alright, so what I have here is some drill bits. And what I'm going to do is try to get a size. That's a little big. Am I blocking the camera? I don't know, I might be. So I'm kind of messed up that way. I don't know what size this is. No, it's the next smallest size. Of course it is. But you know what? It works. What about this size? Does this work? It does. Okay, I'll use that. Tiny, tiny, itsy witsy, teeny wee. Just wait till you see the drill I use for this. Oh, and that's why you had fallen out, because you didn't fit in there very nice. Alright, put this away. And still don't see any comments in here with dad jokes. Nope. Nobody's bringing the dad jokes. Man, I was hoping to get more entertaining than that. Oh, no. My drill's too big. Yeah. That is not going to work. Alright, I guess we're going to do it by hand. Okay. So, if I'm here, I can be here. Alright, so B and N. The first hole's in B and N. So I'm just going to take this right here. Oh, I wish I had the proper... that wasn't too bad. Need a itty bitty teensy weensy drill for this. This is totally the right way to do this. Right? Oh, for heaven's sakes. That was not an ideal outcome. I don't know. I'm always... what is this? I have no idea what this is. I think it's a magnet. It is kind of. But it's a magnet off of something. Oh. Ta-da! Alright. Wait. What? I just lost my whole... ah! Is it double-sided? There it is. I lost my location because I'm a genius. Alright, I think I need to go up a size on the drill bit. Yeah. Alright. Go up one size from a 60 to a 59. Probably doesn't make much of a difference, but we're going to try it. A drill would be handy. but I don't have one this small. Still no comments. Nobody finds this interesting enough to leave a comment. Alright, that is almost it, but not really. Thing is, to go bigger means that one, and that's probably way too big. Wait, there's some... There's some other ones here. What are these ones all about? That's pretty tight. You know, something tells me once you get down to this small that it doesn't really make much of a difference. Nope. Yep. And nope. Yep. Okay. So I'm gonna go with this one. There's no way this is not too small. This might actually be too big, but in this case I think it's all right. Really? There we go. This is going to be some super exciting material. Yep, that works. Do it again for N. Right here. Oh, if only I had a drill. I don't suppose this would fit in the drill, would it? Ooh, this might actually work. Yes! Mucho better. All right. So now we have that one and that one. All right, cool. 60B. All right. I'm following what I'm doing is I'm following the letters and numbers on these. I guess it's 90B. Where is it? Did I just mess up? I messed up. It was 60. Indubitably. Alright, and this one's probably going to be similar. How do I tell? Oh, the other side. Yep, 60. Okay, 60 N. Okay, very good. Now, 2 spaces, 2 spaces. All right, that goes in there. There it is. All right, so on the back side, the reason I didn't mind, all right, so here's why I did not mind doing that with the holes, because what I'm going to do on the back side is I'm going to fold these pins straight over, just like that, because I'm going to use this second row, or this first row right here, for that power rail. And then I need to ohm these out, these coils. It's supposed to be 2 separate coils. So I am going to ohm them out to find out. Alright, that doesn't seem to do much. Really? What? Okay. My shit doesn't work. That's cool. Not. Interesting. What about... nothing? Huh. Okay. Turns out you cannot use an oscilloscope lead on a multimeter. Now I need to find regular leads. Do I even have regular leads? Oh, I have some really cheapos. Okay. This chair is a lot of garbage. That was interesting. Now it works. Alright. Alright, that one is connected. That is not. That is not. This one is connected. That is not. That is not. So, probably could have called that Group 1, Group 2. Now, the real trick is I need to parallel Group 1 and 2. That means I need the positives together and the negatives together. So what I'm going to do is I'm going to fold them this way and this way, but I need to know which ones are positive and which ones are negative. So what I'm going to do is I'm going to go ahead and solder my pins in here in a fashion that will allow me to hook up voltage and actually test. Right? I can solder them that way. Yes. I just need something to hold them into place. Alright, that means it's time to get my soldering iron out. I love this soldering iron. Love it. Definitely love it. Alright, now, solder some tip tinner and my cleaner gadget. Okay. Let's get some bridge wire going here. Got a couple pieces of bridge wire here from the last project. I say bridge wire. I call it bridge wire. It's just scrap wire left over like from the ends of resistors and stuff. So I'm going to put this wire down in, all right, 1, 2, 1, 2. I guess there is no center. We'll just use that. Okay. That works. Now, where's my power? There it is. This thing is great. It's quick. Alright, we just set the temperature. We're going to turn it up. 320. And once it gets up to temperature. It really doesn't take long. All right. Ooh. Good God. Yeah, that's about it. Thing is nice and fast. Look at that. It's beautiful. Love it. Where's the end of my solder? There we go. Plenty of it. All right. Now, go ahead and get some solder on here. All right. And get some solder on here. You know, having all these solder fumes in my face makes me think maybe I should invest in a fume extractor. Probably not a bad idea. Okay, now the trick now is to get this piece in. Tweezers are your friend. Is it this one? Nope. This one. So the trick is to get this one in and get it to stay there. So if I can prop this against something, so that I can get to the back side. Of course, I just knocked it out. You know what? They make things for this. Helping hands is what they're called. All right. Okay. Set this over here. I'll get this. Oh, literally just pushed it out. I am fucking banging a million today. Okay. Now, I should be able to get this. There we go. Man, very nice. Now, I should be able to get this one soldered up better too. There we go. Beautiful. Beautiful. If I really want to, I can get some in the rest here. Just to kind of reinforce it. Doesn't really matter though. It's not carrying high current. It's not even an amp. All right. Now I'm going to go ahead and turn this off. Cool. So now I have a connection point that I can hook up 110 volts to this point right here. I know it doesn't seem like much. It doesn't need to be much. Give it a little bit straight because I'm OCD. Yep. I'm going to trim off the excess. right here. Right. Oh, looks like I got a little carried away with the soldering. No biggie. All right. Cool. So now that I have 110 volts connection right there, I can start to connect that up. And let's see. So I have this jumper here, and I need to supply. How did I do that over here? Did I not have? Did I have 100? I need to supply it with 110 volts. What am I going to do that with? Does it have to be 110? Well, that's the only alternating current I have, so yeah. Alright. What I need is, I can put this on here, and put this connection right here, and then I need almost like a sacrificial element. LTA chip. Yeah, this is not really a great idea, but it's kind of the only one I have right now. I'm going to take these wires. Oh, this is going to be bad. This is going to be really dumb. Don't strip wires with your teeth. You know, maybe I could do this a little better and at least put like some insulation on it or something, like solder it. See, the problem is these jumper wires, they're super fine. Again, it shouldn't matter. This is minimal current, so it genuinely should not matter. That's DC. So now I need a plug. Ta-da! Here is my plug. Alright. How am I going to connect these two up? How? Really? Am I really going to do that? I don't think so. Here's an interesting tidbit. In case you guys didn't know, when you're looking at a plug, these plugs are polarized. Polarized means they only go one way, the directional, right? So a polarized plug, the fat side is neutral. Just a little tip. So if I follow the neutral side on this, our neutral side is striped. I'm just going to do something stupid. That's what I'm going to do. Yep. I am just going to do something stupid. For testing purposes only. This is when I say, we are professionals. I'm not. I mean, I'm a professional, but not at this. This is genuinely kind of dumb. Yep. I'm gonna say this is certifiably not smart. Probably should not be doing this on camera. Oh, for Pete's sakes, you pain in the butt. That's alright. Be a pain in the butt. Just continue to be a pain in the butt. All right. Again, this is for testing purposes only, just because I need to identify the polarity of this transformer. All right. This is fine. It's fine. We're fine. Everybody's fine. If it goes poof, it won't go poof. See? It didn't go poof. All right, now I take my amazingly high-end leads here, and I go, this should be 8 volts, 10 volts. Really? Why is that 10? Huh. All right, now to neutral. So neutral's here. That's 4.85. So this side's neutral. 5, 5, 1. Wait, what? 6. Really? All right, this is weird. N 4.9, 5.7, so this is bigger. 5.7 and 6, so this is bigger. Okay. Unplug this. And my lights cut off? And then come back on. Well, that was strange at least. Okay. Let's take our janky, super janky arrangement out. Alright, what I just did is determined that the transformer is neutral biased on these 2 pins right here. So what I'm actually going to do is I'm going to bend these 2 pins back. Okay? So I'm bending these 2 pins back like that, and then I'm going to bend these 2 pins forward. Like that. That way I can look at it and determine I need to connect these 2 and these 2 for parallel. All right. Now that I got that figured out, now we start the circuit layout. So I want to build my rectifier. I'm going to need 4 diodes for that. 1, 2, you know what, I should put these up here. Put the parts up further so I have room to work. I also need to identify the 2 220s. I believe that's these right here. And then the other ones. There should be a 100 ohm and so on. Okay. 2, 3, 4. 0. Did I lost a diode? Did I lose a diode? It seems like I lost a diode. Alright. That's fine. I have more. So, one of the things I like to do when I'm laying out a rough draft like this, if you look, you'll notice that I know it's a little bit messy, but what I try to do is I try to maintain a sort of a ladder diagram on the circuit board itself. So what I'm going to do is lay these diodes out in a fashion that I can have a positive and a negative, like, naturally. It just makes more sense, I feel like. Alright, so I'm going to go ahead and use the top, well, the top here, It's actually the bottom on this. I'm going to use the bottom, so I'm going to go ahead and do this as the negative. All right, so I'm going to take, I want my diodes to lay like that. I'm going to take, pinch it there, bend it like this, bend it like Beckham. Yeah, I know, I just said that. All right, and then, nope, this is going to have to go out further. Yes. I mean, I can use that hole. That's what she said. Right here. And, oh, try not to lose it. You are ridiculous. Why am I ridiculous this time? Like, I'm not arguing, but why this time? Okay. Now I can slide my diode in here. If I can hit the hole, throw some fur around it. I did a wonderful job. All right, so what I'm going to do at this point is on the back side, I like to use the leads that I have to basically determine to use the leads as the wired connection points. Sorry, I got a bag covering over the comment section. I got too much stuff. Too much stuff. All right. That did not bend up very well. So I I did that in the wrong direction. Yeah, I did. I bent it in the wrong direction, or I placed it in the wrong direction. That needs to go towards. And this needs to go here. Yeah, that works. All right. Now, the next diode needs to do the same thing, but that one connects to this point. And this diode lead can actually go this direction. All right, so I'm going to have another diode facing away. So the negative diode. And I put it down. And this time I'm going to have it connecting to this pin right here. So I want to bend it right here. Right? And then I want to bend it right here. Sure wish people would leave more comments. This would be a hell of a lot more entertaining if people actually engaged. Okay. I'm actually taking up a lot more space than is necessary for this. Alright, so now I'm going to bend this one, and I'm going to try and tuck it underneath this pin. Nah, it can be on top. Oh, out of there. That's fine. It can be on top. Bend it underneath that one. There you go. Okay, so I'm starting to form a pattern here. Alright, so I got that one. That goes to there. And there. Alright, so that feeds that side. Alright, good. And that feeds that side, so that's negative. Now, if I come from this end, oof, this gets a little trickier But if I put the next diode right, so if I come through, oh, I can come through here with the next diode. Yeah, I can come through there, and then it'll be right there. Just wrap it around. Mm-hmm. And this. Save those. Okay. All right, so if I come, now the next one needs to be the positive rail. So if I come, yeah, let's give us some more room here. So I'm gonna go ahead and plonk that down right there. This may end up taking up more room than I want it to, but it happens. Okay. So I got that. And then I want to bend this one right here. Alright, so these two diodes are facing in. And this one I'm going to put right here. And right there. And that should be facing out. So that's going to be the positive bus. Bend that over. Bend this over. Alright. So that's my positive bus. And then I'm just going to curl this around like that. Okay. I always feel like I'm doing something wrong when I'm doing these. Every time. Makes me nervous as hell. Alright, so that's the negative bus. That's the positive bus. And this one, I'm going to... You know what? I'm going to put it right there. That's two away. Man, if I could slip it right there, that'd be awesome. I guess I can put it right there. The reason I can't. Alright, and if that's right there, then this can be right here. Okay. Alright, and my positive lead goes right over top of that one. So that's right there. And right here. Oh, right here and right here. Okay. Then I take this one and I'm gonna pull it right there. Put it underneath. Just so that it kind of hugs it there. And then bring this right around. Okay. Now, let me just double check this. So I've got neutral, neutral, right? Going to... So I've got two neutrals. The neutral, they're joined together, so that's the neutral bus. And that should have... So that's the bottom two, so that's positive, negative, all right, coming out, going in. And then the positive side, those two are joined together, and that's going in and coming out. So if you compare that, Really? What did I do? So, rectifier, if we bring up the diagram, then this here, right here, you'll see the rectifier. We've got this line coming in, right? And we've got one diode pointing in, one diode pointing away, right? So in here I've got, let's say this is the neutral side, I've got one diode pointing in and one diode pointing away. Then on the line side, right here, which is, this side, one diode pointing in, one diode pointing away, right? And those are the top two, one diode pointing in, one diode pointing away. So that is how to lay out a full bridge rectifier in ladder style, essentially, not in the diamond formation. Like, the diamond formation is easily recognized and the most popular way to draw a full bridge rectifier. This is the easiest way that I feel like to lay it out. If you'll notice, I do the same thing on this one. So I put my diodes all in line here, and they're following the same pattern. In fact, you'll see that quite a lot on everybody's circuit boards. It's just the easier way to lay it out. So now I'm going to go ahead and solder these connections in, make this permanent, and yep, that one needs to go there. Trim some of this up a little bit. Once we make this permanent, then we'll move on to creating, moving on to the rest of it. You want to solder, like, you don't want to go too far in your layout before you start soldering things down, only because you don't want to, if you don't start fastening things down, then stuff starts flying all over the place, and nobody wants that. Nobody wants that. But our next part of the component is the voltage drop circuit. So our next part of the component to lay out is this voltage drop circuit that has the 50,000 ohm resistors. What I'm actually going to do is I'm going to pull up my resistance color chart, because I don't know my colors that well, and I'm going to say I have a red, purple, yellow, red, purple. No, that can't be right. That can't be right. Brown? It's got to be brown. Okay. That's 220 ohms. Let me double check with the semi-accurate, fancy-dancy meter here. Oh yeah, 217 ohms. That's my 220 ohms right there, 220. I'm going to set that over here. Same thing with this one. Red, and brown. Those are 220 ohms. What I'm looking for is my 51,000 ohms resistors. So I should have two of those. This looks like they'd be the number. And that is green. Already a good start. Brown. And orange, I believe. Yep. All right, so these are my 51,000s. That creates the voltage drop that I need to send to the one side of the comparator. So that'll be the next thing to lay out. And I'm kind of thinking I need to fit a capacitor. Right here, and I need to fit a Zener diode right here. Once I do the capacitor and the Zener diode, pull up the wiring diagram. So I need to fit, capacitor, Zener diode. Oh no, Yeah, I definitely don't have room for all that. I'm going to have to bridge the DC bus up and then go this way further. So I'm going to have to bridge the DC bus up and then go this way with it. So unfortunately, I don't think I'm going to fit everything in here unless I did some weird stuff. I don't know. Should I do some weird stuff? Like more weirder than normal stuff? Okay, this should be... So, what do you mean setting? It's not even warm yet. What happened? Oh, that's odd. I must have done something wrong? I don't know, I must have pushed the wrong buttons, I guess. That's odd. You would think I'd know how to use my stuff. Okay. Yeah, so if I took those resistors and I went over here, I could actually on the back side bridge this over, because I do have some unused space here. Or I could use the Zener diode into the space further. No, because the Zener diode has to be after. Yeah, the Zener diode has to be after, so I need a resistor. And yeah, on the DC bus, I need a resistor. So this is the DC bus and a diode. What I can do is put the resistor there and the diode. So if I sorry, I'm doing a lot of stuff in my head, so let me point out. So if I put the resistor here, right, I can actually put the lead on the backside coming back. So I can double up on the space and then come back out here and then put the diode in here, like a short diode in here, and then have the DC bus where I do the capacitor and the Zener diode. I'm going to try that. That's what I'm going to try and do. And that means we're heated up. Let's get to soldering. Do 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 do. All right. Put some. Oh, that's nothing. Here it is something. All right. And then here we're also something here. Right. And then on this, we definitely want a bridge to that. Put some in here. Bridge to this. Okay, put some in here. Bridge to this. All right. Now I'm going to bridge to this. Right there. Put some right here. Okay. Now we have our rectifier. No biggie. Okay, now that we have a rectifier, I'm going to do, like I said, I can take this connector off. Huh. Oh, that's what happened. That wasn't even attached completely. Good lord. Gotta watch out for that. Okay. Yes. All right, so that terminal's there. Those terminals are there. That's paralleled up. All right, good. Should be good. Now, like I said, if I take my 100 ohm resistor and I come out here with the 100 ohms, I'm actually going to try and bend this back a little bit. Right, just to give me some clearance. Because the other thing I can do is I can come off the back with the two parallel resistors. Yeah. On the back side, I can take the two parallel resistors like right here. The 50,000, 51,000 ohm to here and then to here. And then that'll give me the voltage drop there. Or I can take it to here and then run it on the back side. Yeah. We are saving space. All right, let me just double check this resistance value. It looks brown, I believe, is 1. Hit the right buttons. Brown. Black? Brown? Yep, 100 ohm. Okay. So once I have this, I can go ahead and put that up there. And then, yes, tweezers here. And put this up here. Yep. All right, so what I'm doing is, seems kind of silly, but this will save a lot of space if this works, right? So I'm coming to here, and then I'm actually going to double back on this. Yes. So you'll see, so this is the positive bus right here, right? We've created the positive side. Now underneath, we have a wire going to here and then back to here. So that should save us some space on that. Let me go ahead and solder that in because that's kind of flimsy. And yeah, so I'm going to solder this in, and then I'm going to solder it. I'm going to solder this joint, and I'm going to solder it to this joint, and then I'm going to solder that joint. In fact, I can probably tuck that down in. I love this soldering iron. This soldering iron is fucking phenomenal. All right. Okay. All right. And just to get it secure. Ta-da! All right. Now, I can take the diode from here over. And in fact, I don't even need this jumper here. Right? Yes. So I'm going to clip that bridge piece. And I'm going to clip this bridge piece. Alright, so now what we have, this might look kind of weird on the camera, honestly. Not gonna lie. What we have here, hold on, I'm just gonna check the time. Oh, we have been on for quite a while. Okay, so, like I said, I know there's a lot of shiny bits, so this may look a little off on camera, so let me try to point this out to you with the back side of this here tweezers. So what we have here is the neutral side of the transformer, and we know this because we measured it. So we applied 120 volts. 120 volts has a line and a neutral, so the transformer is naturally going to be biased neutral and line. So we used our multimeter to determine that this was the bias towards neutral side on the output. So we tied those together because the output needs to be parallel for 8 volts. So we have that tied together, and then we have the bias towards line side tied together towards positive. So the neutral biased is going towards the negative bus, which is ground essentially, and the line side is going towards positive. Now, what we've done, we have our positive side and our negative side. And what we've done to save space is taking the resistor, taken the positive side, so this is positive, we've taken it back, resistor comes through, so it comes underneath, and then it comes out here. Right, now I'm going to tie a diode from here as short as I can, and I'm going to create the positive bus that takes the capacitor and the Zener diode. Right. Now I need the diode that I lost, because I'm good at losing stuff. Alright, these are our two 220s. These are our two 51,000s. That's another janky thing I'm going to do, is I'm going to put the 51,000 resistors on the back here. Janky! I'll just get another diode. Alright. So like I said, I'm going to take this diode literally as short as I can make it fit. Which is not short enough. What I'm doing is I'm laying down the pin, so if you lay it at a 90-degree angle to the side, you can get an idea of where you need to bend it. Is my daughter's calling. Kira went to her grandparents today, and now she's calling me on the Facebook Messenger. So I'll have to call her back. She probably wants to play Minecraft. Alright, so I'm going to take this here diode. Now, the key part to this here diode, alright, in case you guys... I mean, I don't want to make assumptions, but, right, so you might as well point it out. When you're putting diodes in, the line on the diode... Oh, good lord. Cathode? I think it's it's the positive side of the diode. So you want that to be, you want the line, the white line on the diode to be in the direction of current. So I'm just going to take this and put it right here. Ta-da! Alright. Now I can fold this one side down to create... What I'm doing is I'm using the leads. So I use the leads of the components. It's beautiful for prototyping. To create the wire connections. Like if this were a circuit board, then the pathways would be drawing on there for you. But in this case, when it's just a prototype board, you don't have pathways. Now some guys will like create strings of solder. I like to use the leads of the components to create the pathways on there. So I'm going to bend that down there, and then that can actually get soldered. And I don't know what I want to do with this side. I need to bring the capacitor and the Zener diode in there. And if I bring the capacitor and the Zener diode in there, if I bring the capacitor, what do I do with the capacitor? It's right here, right in front of my face. Straighten the leads out a little bit because they're kind of... All right, that's the negative. So if I do the capacitor, because I can do the same thing with the capacitor. I can actually take the lead, so I can bring the capacitor back a little pace. I can bring it back a bit. And then I can put the Zener diode right here. Again, the Zener diode is very similar. There's a black stripe. There's a black stripe. That's where you want that to be towards the positive. All right, so if I did that, I think actually I want this one to be right here. Like I can be on either side of it, right? And then I put the diode here. So if I put this here, or I can put this right here. All right, let's see. I can put the... Oh, man. Oh, wait. Nope, it is. Okay. So, what row is that? That's E. Row E. Of course, the letters don't change over. Okay, so I want it to be on this side. Right? Okay, so if I do that, let's just bend this over to hold it in place. Then I can easily put the Zener diode right here. Right? If I put the Zener diode right here, then I can use... If I put the Zener diode right here, then I can use the lead of either the diode or the Zener diode to bring the positive bus up, and then bring the negative bus up on the back lead. Yeah, because I'm going to need to come up here. I'm going to need to come up here for my other components. All right, I think that works. I like it. Now, unfortunately, I need to pull the capacitor back out temporarily because I need to solder this component here so that I can cut this lead. All right. What the hell? Did I hit that too soon? Oh, it's heating up. Anyways. Oh, multimeter's buzzing. Well, this video has actually been fairly lengthy, and probably should, I don't know, probably should drop. I mean, we got 4 viewers, but I've got no comments. Create a channel to join the page. And, yeah. I think I'm going to bring the live stream to a close here. Because I've got other things. Got to find out what my daughter wants before she goes to bed. She needs her night-night song. And, I'll keep working on this. But pretty much I'm going to be doing all of the same. I need to add these components yet. That kind of stuff. But for now, I'm going to go ahead and bring it into the live stream. Thank you, everybody, for watching. I really appreciate it. Going to be doing a lot more of this. A lot more of this kind of stuff. There is an end goal, and I got to make a video about what the point of all of this is, because there is a point. A very interesting point, I think. A very interesting point. But, yeah, so thank you very much, everybody, for watching. I'm going to cut the video now. I'm going to continue working on this, and probably tomorrow or the next day that we do a live stream, I'll have this built. We'll show it off and talk about it, you know, because maybe some of you guys will actually have some questions and comments or some dad jokes that I keep asking for. Anyways, thank you very much, guys. Have a good one.